Filters. So what are the filters we know, and what will be the applications of the filters when it's come to the system electronic system design, and what are the applications, what are the concept of filter when we apply this concept into our designing. So filters are basically the circuits the capable of passing or attenuating the frequencies. As a definition, filter can be filter is a circuit capable of passing certain frequencies while attenuating other frequencies. So there are four main type of filters. There will be several other filters as well. These are the four main types of filters. Low pass filters means low frequency, the filter which pass the low frequencies only, and the high pass filter which pass the high frequencies, and the band pass, the filter which pass only the our certain bandwidth of the frequencies, and band reject filter will pass the other frequencies but reject the our bandwidth. Okay. To learn about, to get the idea about the filters, we need to have a normal idea about what are the characteristics of filters. So there will be a cutoff frequency as well as the center frequency, and other several parameters also. So we will learn about these parameters in the next couple of minutes. So characteristic of filters, we are, so in this session also we, as I said earlier, that we look into the parameters that required to understand the filters. So first thing is cutoff frequency. In here also in the here the cutoff frequency is the F1 and the F2. So what will be the cutoff frequency? What will be the cutoff frequency? And cutoff frequency is the in the corner frequency or cutoff frequency is the break frequency of the boundary in the system frequency response at which energy flowing through the system being to reduce means attenuated rather than the passing through. So here you can see that in the low pass filters these frequencies are passed, but after the 3 dB mark, in here also after this mark the frequencies will not pass. This will be the stop band. So only up to this part, the frequencies will. Let me draw again. Up to this part, the frequencies will pass. After that, in this part, frequencies will not pass. When it comes to the high pass, up to this part, frequencies will not pass, and from this, frequencies will pass. So this point, the frequency of this point, we will talk about as the cutoff frequency, FC. So how do we determine the cutoff frequency? The input frequency that causes the output signal to drop by minus 3 dB relative to the input signal. In here, you can see that this is the input frequency. This is the input frequency. After certain amount of time, the 3 dB drop is there. The minus 3 dB drop is there. What is the dB? dB means 10 log the ratio between two powers P1 and P2. So the drop of the energy of the particular circuit is causing to attenuate the signal. So we can actually get that mark have a certain standard to minus 3 dB. So if you get the minus 3 dB value from the input signal and calculate the frequency, we can get the cutoff frequency. Okay, the next thing is center frequency. The center frequency is only applied for the band pass and the band reject filters. So band pass and band reject filters only have the center frequency. Center frequency is the center of the bandwidth, the band which passes or reject. So it can be arithmetic mean. It can be the mean of the lower cutoff frequency and the upper cutoff frequency. So when it comes to the low pass or high pass, it will be only one cutoff frequency. But in the band pass or band reject, there will be two cutoff frequencies, since it will not focusing on the high frequencies or low frequencies, just get the middle portion of the some frequency range. It can be a high frequency or it can be low frequency. Okay, this is in these two, they will look for the certain just certain boundary, like this part pass, this part attenuate, or this pass attenuate, this part pass. This is low frequencies, high frequencies attenuated, high frequency, low frequencies attenuated, high frequency pass. But for the band pass, they only reject the some middle frequency range and passing others. So for the notch frequency, so they will not pass this band, and sorry, this for the others will be not passing, and only the band will pass. So for the notch filters, the middle frequency band will not pass and other will be passed. This is attenuated. This one will also, the other frequencies will attenuated, and for the high pass, low frequencies will attenuated. For the low pass, high frequency will attenuate. To get the center frequency of the band, so we will get the arithmetic mean. So to get the arithmetic mean, we will use this equation. Okay, now the another parameter, bandwidth. What is the bandwidth of the filter circuit? Bandwidth of the filter circuit is the width of the pass band or rejected band. So if you want to get the bandwidth of the filter circuit, just take the difference between two cutoff frequencies. Something like, let's say the F2 is the cutoff frequency of this upper cutoff frequency. F1 is the lower cutoff frequency. F2 minus F1, we can get the bandwidth. Okay, then other thing is, with the bandwidth, we can have a Q factor. The Q factor is the parameter to measure how selective or unselective of the band pass or stop filter toward the given requirement. So to given spread of frequencies. To select a band pass or band reject filter, we need to have a clear idea about the Q factor. So the basic principle of when we selecting a band pass or band reject filters is if the lower the value of the Q factor, the wider the bandwidth. Lower the value of the Q factor, wider the bandwidth. That's the main principle. So the higher Q factor means narrower the bandwidth. If we get the correct Q factor, actually we can have a normal idea about is it suitable or not for our requirement. So Q factor is, we can calculate the Q factor from this equation, the resonant frequency and the bandwidth. You have idea about resonant frequency from the RLC circuits. So if we calculate the resonant frequency, with the bandwidth. If since mostly the bandpass and the notch filters are equipped with the RLC components, so we can have a idea about Q factor. Okay, since you know about the characteristic of filters, then now you have a normal idea. So we will move on to the passive filters that which can be designed from the RLC components. So passive filters only consist of the passive components, resistors, inductors, and the capacitors. And when it comes to the passive filters, one of the main factor is there will be no amplifying elements like transistors or op-amps, and it can be only used that the normal rule of thumb for the passive filters is it can be only used in the frequency range from the 100 hertz to 300 megahertz. And to have a passive filter using RLC components, we need to get a normal idea about inductors and capacitors. Inductors will block the high frequency and conduct low frequency, and the capacitors will block the low frequency and conduct high frequency. Inductors will block the high, capacitors will block the low. Low in inductors high. And these passive filters are have several applications, mainly in the radio frequencies, and to reduce the unwanted signals in the power supplies and audio electronics, mainly in the audio electronics, but mostly audio electronics use the active filters and also in the analog to digital conversion circuits as well. So one of the passive filters, though now we are talking about when we are getting idea about the passive filters. So there will be low pass, high pass, and the band pass. So low pass filters will have a certain cutoff frequency, and after that frequency, attenuate all the high frequency signals. So you need to develop the transfer function of the RC circuits, RCO, RL, low pass filters. So to get the transfer function, V out over V in is the basic equation, and we will get the frequency domain expression of these two components. After getting the expression for these components, we can actually build up this equation. So cutoff frequency for RC low pass filter is 1 over RC. Cutoff frequency for RL low pass frequency filter is R over L. So you can actually have a pace of these circuits as well as the transfer function of this circuit. Okay, so now we are moving to the band pass filters and the band stop filters. So band pass filters are only allowing the required band of frequencies to pass, while others are attenuated. So if you want to get the bandwidth of this circuit, we need to have a higher frequency cutoff and the lower frequency cutoff. The difference between two will get the pass band. So this will be the pass band, and same minus 3 dB principle can be applied to both ends as well. So after applying the minus 3 dB principle, we can get the cutoff frequency of this one and the cutoff frequency of higher end as well. For the band stop filters, it will consist of three different circuits, three different sub circuits. It is low pass, high pass, and the amplification thing. So low pass filter only pass the low frequencies and attenuate the certain high frequencies, and the high pass filter attenuate the low frequencies and pass the high frequencies only. So if some circuit, some let's say some signal with the our required frequencies comes, these signals feed into these two sub blocks as well. So low pass frequency, let's say we build up a frequency range of 100 to 900. These frequencies stopping. So let's say we will have 80. So these two frequencies feed into these two blocks. So low pass filter is passing lower than the 100 hertz. So it will pass the signal. But high pass filter, sorry, I low pass filter will pass the 80 hertz signal, but high pass filter will not pass the uh, high pass filter not pass the 80 signal, since it is only passing after the 900 hertz. So low pass filter only pass the below 100 hertz. So let's say now we get the something like 500. It goes to the low pass filter. It will not pass, since it only pass the below the 100 mark. High pass filter, it will only pass above the 900 marks. So only 80 and let's say 1000 hertz will pass through the high pass filter, then go to the amplification and get the as a V out. For the band pass filters, it will be only the required band is passing. For the band stop filter, only the required band is not passing, it is attenuated. Okay. The high pass filters will have a high pass filters will only dealing with the high frequencies, but attenuating the lower frequencies. It is same principle for as the low pass frequency, same cutoff things as say cutoff equations as well. So these kind of signals, these kind of circuit subsystems will use to attenuate the lower frequencies on audio amplifiers, like the if we separate our audio signals into the bass and the if there is a home theater systems, they will use this kind of circuits to get the separate circuit and amplify to has a bass circuit. Okay, that's all for the theory part of this session. We will have a discussion later. I think sound is not there, so I will start over. So filters are the circuits capable of passing certain frequencies while attenuating frequencies. So main type of filters are low pass, high pass, band pass, and the band reject. There is certain parameters when it's come to the characteristic of filters: cutoff frequency, the center frequency, the bandwidth, and the Q factor. Okay, the rule of thumb for the passive filters will be, it will be used for 100 hertz to 300 hertz, 300 megahertz, and there will be no amplifying elements. The only principle when it's come to the passive filters we need to memorize is inductors will block the high frequencies and the capacitors will block the low frequencies. There are certain applications like radio communication, DC power supplies, and audio electronics. And so for the low pass filters, to get the correct idea about low pass filters, we need to have a transfer function of the low pass filter, and cutoff frequency of the low pass filter come from the equation for the omega angular frequency. And band pass filters dealing with the bandwidth, the high cutoff frequency subtract from the lower cutoff frequency, will get the bandwidth of the particular band pass filter. So band stop filters will have three basic components: low pass, high pass filters, and the amplification part. And for the high pass filters, the same as the low pass one, and this has a special use of the high uses like attenuating lower frequencies in audio amplifiers. Okay, I think you have a normal idea about what are the passive filters and what is the idea, what is the how these passive filters behave. And to get a clear idea, you need to get the idea from the RLC circuits as well.